The number system we are familiar with is decimal. In decimal number system, we have these digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. It means that we can represent 9 objects, up to 9 objects by a single symbol. If we have, suppose, one person, then this can be represented by the number 1. Similarly, if we have 9 persons, we can represent it by a single symbol 9. But if we have 10 persons, suppose this drawing is my persons these are my persons. To represent these many people, we can't represent by a single symbol. We can only represent 9 people with this symbol. So to represent these set of people, 10 people, we have to use two symbols from this set, and we use 1 0. That is, we can't represent these many people with a single symbol. We use two symbols, these two symbols, to represent these people. But in hexadecimal number system, we have some more symbols. This symbol is used to denote 10. Similarly, B, C, D, E, F. These symbols are also part of hexadecimal numbers. So B can itself represent 11 objects. C can represent 12 objects. D can represent 13 objects. E can represent 14 objects. And F can represent 15 objects. Thus we see that while in decimal number system, only up to 9 objects could be represented by a single symbol, in hexadecimal number up to 15 objects could be represented by single symbol. So if our number system is 16, let us say our number system is hexadecimal, and we write F, this single symbol would mean 15. So we can represent up to 15 objects by a single symbol, and only after this boundary, that is 15, we need to combine more symbols to represent objects. If we want to represent 16 objects, we run out of symbols in hexadecimal numbers. In hexadecimal number, this F is considered as a digit and it represents 15, but after this we have no other symbols. So to represent 16, we have to combine these symbols. We have to use two symbols as we did after 9 in hexadecimal. In decimal we used 10. Similarly, in hexadecimal, after F we use 10. So 10 in hexadecimal would mean 16 in decimal. 16 in decimal, 16 objects could be represented by 10 in hexadecimal number system. Now I am considering conversion of hexadecimal number to decimal number. Let us start. As we talked in binary number system and octal system number system, that the place value in these number system increase by radix to the power 0, radix to the power 1 and so on. In the case of binary digit, it increased from 2 to the power 0 to 2 to the power 1 and 2 to the power 2 and so on. And in octal number system, it increased from 8 to the power 0, 8 to the power 1, 8 to the power 2 and so on. Similarly, in hexadecimal system, it will go like this: 16 to the power 0, 16 to the power 1, 16 to the power 2, 16 to the power 3 and so on. Now 16 to the power 0, 16 to the power 0 is equal to 1, 1, 16 to the power 1 is 16, and 16 to the power 2 is 256. Hope I am right. And and 16 to the power 3 is equal to 4096. These are the place values in this will keep on increasing in this direction: 16 to the power 0, 16 to the power 1, 16 to the power 2, 16 to the power 3 and so on. So if my number if my number is let us say 1 9. This is in hexadecimal. It will mean 9 into 16, 9 into 9 into 1, 9 into 1, that is 9, and plus 1 into 16, 1 into 16, that is 16. So if we add them up, it will become 25. So 19 written in hexadecimal would mean 25 in decimal. Let us take another example. Suppose my number is 5A. It is written in hexadecimal. You must remember that A is a symbol in hexadecimal number which is equivalent to 10 of decimal number system. So this is a valid number in hexadecimal number system. So in this case, here I will multiply. In this case, A, that is 10, into 1 will be 10, 10 into 1 will be 10, and 5 into 16 will be 80. 5 into 16 will be 80. So the number becomes 10 plus 80 is equal to 90. Thus 5A written in hexadecimal will be equivalent to 90 in decimal. I will take more examples of hexadecimal to decimal conversion and vice versa in my later videos. Keep watching my videos, and if you find them useful, please subscribe to my channel. Thank you.